So when you see a question like this, just pay attention to the basics, like units, because they give it in moles and liters, molarity, and then make sure to understand if they're asking pH or pOH. So for this question, the first thing you want to do is set up an ice table just to get your bearings. So first you can set up a chemical equation. So acetic acid is HC2H3O2 aqueous, and then it will ionize into C2H3O2 minus NH plus. So then you can set up an ice table. So you look at the information given. So the initial concentration of acetic acid is 0.25. The initial concentration of this is 0.075 moles. Pay attention to this because, since it's in moles, they can trick you, because if this was 2 liters, then you'd actually have to divide 0.075 divided by 2 to get your molarity. Because in an ice table, you can only have molarity, not just moles. But for now, it's just 1 liter, so it'll just be 0.075. And since they didn't specify one, it'll just be 0, because this is the initial condition. So then you're going to, since there's a 0, it's going to go to the right to make more products. So it's going to be minus x plus x plus x. If you just think about it, it couldn't be minus x, because you can't have a negative molarity. So this is going to be your equilibrium. So now since you're at your equilibrium, you can have your equilibrium constant, which is going to be Ka, because this is an acid. So your Ka is simply products over reactants. It's going to be 0.075 plus x, and then your reactants, which is going to be on the denominator, 0.25 minus x. And if there was a coefficient, then you'd have to put it, you'd have to raise it. But now everything's 1, so you just raise everything to the 1, so it just stays like this. So now what you do is, if you have your Ka, which they'll probably give you, 1.8 times 10 to the negative 5. See, this is such a small number that even if you added it or subtracted it, it wouldn't affect it, because it's such a small number. You can get away with not using it and still have an accurate answer. So you can get rid of the x's, or the plus x and minus x, and then solve for x. So you get x as 6.0 times 10 to the negative 5. So if you look at this, you look at what is x. So x is actually equal to your hydrogen concentration. So that's actually pretty useful, because our question is, what is the pH? So now since you have your hydrogen concentration, you can use the formula which links pH and hydrogen concentration, which is pH is equal to negative log of hydrogen concentration, which is equal to this. So you just plug it in, and then it becomes pH equals 4.22. And then remember that when you have logs, the sig fig rule for logs is that if you whatever amount of sig figs you have here, which is going to be 2 for this one, it's going to come after the answer. So since this is 2 sig figs here, it's going to be 2 sig figs after this decimal point, and that's what we have. So the final answer is 4.22.